We've talked about aperture a little bit. Let's spend a little bit more time talking about it in some detail. To refresh, aperture simply means hole. And it's talking about the hole in your lens and how wide that hole is open is what the aperture dictates. It's one of the three legs of the exposure triangle. What are the other two? Shutter speed and ISO. It helps define exposure. It helps control depth of field. And your lens is at its sharpest when it's closed down a couple of stops from its wide open position. So how do we measure it? It's expressed as an f-stop. It's written as a lowercase f with a slash because it's short for fractional system. The equation is focal length divided by aperture diameter equals f-stop. So a 50 millimeter lens, a 25 millimeter aperture is f2.0. The math results in an inverse scale, so it's a little confusing. And it's worth knowing that a given aperture, f4 for example, always transmits the same amount of light. It doesn't matter what lens it is. It doesn't matter if it's an 18 millimeter wide angle, a 50 millimeter normal lens, a 400 millimeter telephoto. It doesn't matter if it's a Nikon lens, a Tamron lens, a Sony lens, a Zeiss lens. F4 is F4 is F4. And that's really convenient when you're starting to work in manual. Why do we care about aperture? Well, as we've talked about, it helps control the exposure. It definitely controls your depth of field, what's in focus from front to back. And it has a lot to do with image sharpness. So let's talk about the exposure piece. It controls the amount of light coming through the lens. Wider, bigger, faster apertures, smaller f numbers, let in more light. That makes your photo brighter. Narrower, smaller, slower apertures with bigger f numbers let in less light, making your picture darker. So if your picture is too dark, open the f-stop up. If your picture is too bright, close that aperture down. Big f numbers equal big depth of field. Peterson calls this a storytelling aperture. Your subject and your background are sharp. This picture was taken at f13. Notice she's sharp. Notice the building behind her is sharp. Notice the building behind that building is sharp. Wide depth of field. It's a small, narrow, closed aperture, so you need more light, meaning either a slower shutter speed and or a higher ISO to get a correct exposure. Here's the exact opposite. A small f number is small depth of field. It isolates the subject from the background, a single subject. It draws the viewer's eye to that subject very effectively. This was taken at f2.8, and we can see the little vial is in focus. Her fingers are a little out of focus, and her face is very out of focus. It's a big, wide open aperture, and it requires less light, allowing for a faster shutter speed or a lower ISO or some combination of those for correct exposure. It also affects your image sharpness. Most lenses are not at their sharpest optically when they are wide open, whatever that wide open is. They're sharpest in the middle of the range, and then it degrades again when you stop it all the way down. You want to work in the middle of the range unless you have a creative reason not to. More money gives you more sharpness, and expensive lenses are much sharper wide open. And this is critical when you get into industry more so than as a student. But for example, a 50 millimeter f2.0 lens will be at its sharpest between f5.6 and f8. The 18 to 55 millimeter zoom that comes with most cameras is going to be sharpest at somewhere between f8 and f11. Two photos, both taken at f8. Why do they have different depth of field? Again, in the left, we see lots of focus from the skateboarder, like the mountains are in focus. In the other one, the hairs in front of and behind that mosquito aren't even in focus. Well, it has to do with lens selection and camera to subject distance. All else being equal, you will have less depth of field when the subject is close to the camera. You'll have a softer background when the subject is further from the background. Longer focal length lenses will have less depth of field. This was a 105 millimeter lens. The subject is about 2 inches from the lens, and the background's about 8 feet from the subject. So the background is simply completely out of focus. Here's the opposite. All else being equal, you'll have more depth of field when the subject is farther from the camera. You'll have a sharper background, relatively speaking, when the subject is closer to the background. And at infinity focus, which is the little sideways 8 on your lens, everything is in focus from that close focal length or focal distance out to the next galaxy. Shorter lenses have more depth of field than longer lenses. This was taken with a 25 millimeter lens. He's probably 6 or 7 feet from the camera, which is far enough with that wide lens to start approaching that infinity focus. Add a small f-stop, and we have lots of depth of field. So the assignment details are in Canvas, but you're basically going to produce 2 photos of the same subject, one with shallow depth of field, one with wide depth of field. You should do this by varying the aperture. And here's some examples other students have done. Plants in front of Newton's arrow sculpture as a good example. Out in front of the behavioral sciences building. Here's the classic example. Wide open aperture on the left, closed down all the way on the right, and that's the only difference in these 2 pictures. We see much deeper depth of field in the right image. So to summarize, wide apertures have small f numbers. We use words to describe wide apertures like wide, big, open. They have narrow depth of field, shallow focus, and they isolate your subject from the background. Narrow apertures have large f numbers. We use words like narrow, small, closed. They have wide depth of field. We think of that as a storytelling aperture. Call me if you have questions, and good luck.